There's an old saying in fishery science that goes, counting fish is just like counting trees, but the trees are invisible and they keep moving around. So how do you count trees in this confusing forest? If I could answer that question, I'd probably be giving a different talk right now. But right now in California, one of such counts, or stock assessments as they're called, is taking place of barred sand bass. Barred sand bass historically have been one of the most popular targets for recreational fishermen in the state. This table shows where they ranked among all other species in charter boat landings, which is the number of fish kept per year. This is compared to the usually more than 40 other species or species groups in this ranking, and despite the fact that they're caught almost exclusively in Southern California, they almost never left the top two for the whole state in the mid-90s to mid-2000s, reaching all-time highs in catch volume in 2000. They live mostly shallow and near to shore, and they form large groups called spawning aggregations to reproduce in known locations in the summer months. And for these reasons, they can be easy to target and are accessible to all types of anglers. And not having to travel far to catch them means that they cost less to target than other offshore species. But also for these reasons, and particularly that spawning behavior, they can be vulnerable to overfishing. This figure shows sand bass catch over time. You can see those all-time highs in the early 2000s. But later that decade, catch began to decline dramatically, sparking concerns of overexploitation, which led to stricter management of the fishery in 2013. But catch continued to decline. In 2016, total catch was less than 3% of what it had been in 2000. And since that 2013 rule change, catch has mostly remained below historical levels, and concerns of overexploitation still exist. And so 2 years ago, further stringent regulations were proposed. This proposal sparked a huge managerial debate. In this image, you can see a line forming before the Fish and Game Commission by people looking to give comment on the matter when it came up most recently. These were a few of hundreds of people that participated in advocacy for or against these measures. Much opposition was voiced by the fishing industry, who argued that the fish is doing better than catch data alone suggests for a number of reasons. The fish migrate more than is thought, fishing effort was targeted elsewhere, and to some extent, environmental conditions can affect when and where this fish is abundant. This closed caption is the actual motion that passed. The outcome of this debate was a reduction in the bag limit of fish that fishermen can keep from 5 to 4 fish, but most importantly, the status of sand bass will be reevaluated in 2028. And so back to counting fish, the California Department of Fish and Wildlife has been tasked with completing a stock assessment for the species before then. In order to properly manage this species and its fishery, we need to know how many there are. And to do that, we need a lot of data. Fortunately, there are a lot of programs in California that collect data related to sand bass. These logos all represent different monitoring efforts here. Unfortunately, most of these programs operate independent of one another and across different spatial and temporal scales. The need exists to compare each of these spatially so that we know how well they cover both the places that sand bass live and the places that we fish for sand bass. Without that comparison, different data sources might say different things about sand bass stock, but we lack the spatial reference to know where that difference is coming from. And also without it, the data that we're using to ultimately manage this fish might have gaps that we don't know about, but definitely need to know about, so that the ultimate management decision is based on the best available information. Up until this point, such a spatial reference has not been created that lays all those monitoring efforts onto the same map. So I set out to create such a reference. But I wanted to do so in a way that could communicate a ton of data in an easily accessible visual platform that anyone can use. There are clearly many different stakeholders involved in sand bass management, and having each be able to use this analysis was important to me. Stock assessors and scientists might use this tool to understand the spatial basis for deferring model outputs. The fishing industry, who in the case of the sand bass debate is providing additional catch and measurement data, might use this tool to support their own data collection efforts. And survey programs might use this analysis to know where to prioritize monitoring. I'm a fisherman, but I'm also a conservation ecologist. And one of my goals in this project was to use both of those parts of my identity to navigate what can be, in this case, a contentious line between the two. I care about fishing, I care about this fish, I care about preserving the opportunity to continue fishing for it. And so I wanted to provide something that could address a knowledge gap for all stakeholders. And briefly speaking of knowledge gaps, this presentation represents part of the work that I did for my capstone. The other part investigates a possible correlation between northern anchovy abundance and sand bass abundance, but today I'll just be focusing on the spatial comparison analysis. So let's start with a base map of the Southern California Bight. I wanted to be able to compare all existing data sets to one another, but also to sand bass habitat and range in the US. So I used the area out to 100 meters of depth as a proxy for this habitat, based on the knowledge that they rarely inhabit deeper water and that fishermen almost exclusively target them in shallower water. This proxy is represented by the purple shaded area. The data sets that were added to this map come from two modes of data collection. Non-catch data, also known as fisheries independent data, which could be scuba surveys, science trawls, remote underwater video surveys. Non-catch data is supplied by a number of different monitoring efforts, and I gathered as many data sets as were available to me at the time of this project that are ongoing, record observations of sand bass, and that are being considered for incorporation into the stock assessment. And catch data, also known as fisheries-dependent data, which in this case comes from charter boat logbooks provided by the Department of Fish and Wildlife and summarized for confidentiality. So this is what all those non-catch data sets look like in their raw state laid out on the same map. This represents nearly 5,000 individual surveys across programs, and the methods used to collect these data vary largely across each program and are mostly very site-specific. And so to be able to visualize the collective coverage of all these data sets, I needed a rough way to standardize them. Fortunately, catch data was resolved to preformed blocks by Fish and Wildlife. And so to create some uniform spatial comparison between all these data, I laid non-catch data over the fishing blocks to see how frequently they overlapped, which provides a nice but coarse visual representation of the total coverage of all efforts, where darker blocks illustrate more survey instances in a block. But how does this compare to where the fishing actually takes place? Using the same blocks, this map displays sand bass catch data from charter boats from 1980 to 2025, where darker blocks represent more fish caught per angler, also called catch per unit effort. And catch obviously changes a lot over time, so in addition to just understanding the total comprehensive comparison between these data, I wanted to understand how that comparison has changed over time, which will better contextualize where we are now. And so I divided catch and non-catch data sets into 5-year periods to display these temporal changes, which is being displayed here using non-catch data. And finally, using blocks can make it difficult to pinpoint where efforts are focused, whether that's fishing or monitoring. So to easily digest these comparisons, I generated kernel density estimates, which essentially just create these pretty heat maps. And so here is non-catch data with darker green representing more surveys. And here is catch data where darker represents more sand bass catch per unit effort. And once each of these layers were created, I wanted them to be accessible to any user. So I put all of my map outputs into an ArcGIS Pro Experience Builder web app. Users of this platform are able to arrange layers and slide through time as they please, making comparisons between different efforts and time periods. So let's say that you're Reef Check and you have the time and capacity to add a survey site. And among other criteria you're considering in choosing this site, you want to contribute to our understanding of sand bass ecology. To do that, you're looking for an area that has previously been sparsely sampled. By displaying different layers, by using the pop-ups associated with each block, and by swiping through density estimates, you might look at this tool and realize that, aside from a few trawls, the area off of Oceanside and San Onofre, an area that receives substantial fishing pressure, and also the location of a historically present spawning aggregation, receives relatively fewer survey types than other consistently fished zones. You realize that this might be a gap in our spatial understanding of sand bass and decide to set up a survey in this area. That last bit is true. One of my findings in this analysis was that that specific area has a relatively low number of survey types compared to other consistently fished zones, which is not to say that its coverage is worse, especially since the Fish and Wildlife surveys existing there are targeted towards sand bass, but it can help guide future research to where knowledge is most needed. And looking at a few more of those gaps where red blocks represent areas where catch data occurred, but no non-catch data was recorded, some of these blocks are outside of the habitat proxy for sand bass, and others are outside of commonly fished sand bass zones, which means that they might not be priorities for future surveys. Which all of this is to say that the survey coverage of relevant sand bass fishing grounds and habitat is relatively comprehensive across the Southern California Bight. which is an important conclusion for a fishery where, without a stock assessment, catch data alone as a measurement of the status of the species is scrutinized. Additionally, some of these gaps may close as more data sets become available, in which case future additions to the web app can be quickly made. It should be noted that this output is not meant to be a direct comparison between survey programs and their efficacy at observing sand bass. These survey programs occur using very different methods, and that combined with both the block methodology and 5-year time periods that I use mean that this is ultimately a very high-level view of survey effort. But those comparisons should be done in the future, and so this tool exists as a building block for future work or actions like the stock assessment or the example I described, just not a characterization of sand bass stock in and of itself. And this tool, even in its core state, can tell us that our understanding of sand bass is well represented across space by non-catch data. And hopefully that conclusion can be arrived at independent of myself telling you that it's true, with visual data communicating that information to users of this platform. This product exists with the goal of helping you, your friends, those interested in fishing for sand bass, those interested in studying it, to consider the barred sand bass. And I think that in this consideration, the ecological and human aspects of the species must be held simultaneously. Understanding the fish and the ways that we count it can only help us continue catching it. And I'd like to give a huge thank you to my capstone committee for guiding me to this project and guiding me through it. Lyle, Andrew, Heidi, and Ross, you guys were so extremely helpful. And many thanks to many others, my family for being here, my friends. Thank you guys. And this is a QR code that'll take you to that web app as well, but it's optimized for desktop, I should say.
Thanks, Thomas. Very cool presentation. You obviously did a lot of work and really navigated a complex, data-dense topic with a lot of nuance and a lot of thoughtfulness. So thanks for sharing that with us. You mentioned, you only got to share one piece of the project with us, but you mentioned there was also a portion where you looked at anchovy as well. And I wondered if you could share anything related to that part of the project with us. Yeah,
great question. Yeah, I hope I prepared some slides for this. Just kidding. So this research item, so I did another part of this project that investigated a potential correlation between northern anchovy abundance and sand bass abundance, which was based on speculation from the fishing industry that as I mentioned before, environmental conditions might be able to affect the presence of sand bass or how much they're caught. And in this case, focusing specifically on northern anchovy, which is rooted in the fishing knowledge that anchovy are the best bait type for catching sand bass. Ken Franke conducted a survey on my behalf he's the president of the Sport Fishing Association. He helped me greatly in this project by conducting a survey of 11 commercial passenger fishing vessel captains. We found unanimity in their preference for anchovy as bait, which validated a survey done by my chair, Lyle, about a decade ago. Lyle also found a correlation between anchovy bait availability and sand bass catch per unit effort. But in this case, instead of anchovy as bait, I'm testing anchovy at the ecosystem scale as a potential prey item, where with the logic being that if there are more anchovy present in the ecosystem, then we might expect to see that reflected in sand bass catch if there's more sand bass present. So we might expect to see that correlation in 2 different time periods, either directly, so with elevated anchovy, you might see more sand bass catch per unit effort in the same year, or you might see that in the time that it takes sand bass to recruit to the fishery, so roughly 6 to 8 years later, based on higher juvenile survival with more prey in the ecosystem. And I also use sea surface temperature as a potential or possible additive explanatory variable in this case, based on the fishing knowledge that sand bass bite better in warmer water, and also based on Ken's survey, we found that the sea surface temperature where sand bass begin to aggregate is warmer by about 1.5 degrees than the mean summer sea surface temperature. So using those variables, I tested these correlations, and I could show you the cross correlations and linear models that I ran to test this, but I think that this figure describes it best, which is Sand bass catch per unit effort in orange, and anchovy larval abundance in blue. Let's say that, among other things, the factors that drive high sand bass catch are high anchovy abundance, warm water, and already abundant sand bass, which would be told through catch. But over the 45-year period that I tested here, those conditions have largely not co-occurred, which does not mean that they're not correlated. It just means that in this time period and at the scale that I'm testing, I was unable to find any signals for a correlation between the two, and sea surface did little to add anything to these comparisons.